Welcome to the Sound Matching Game. Your contestants today are Isaac Bovey and Mark Christensen.
I'm Isaac Bovey, and
I'm Mark Christensen.
we're doing the sound matching game lab together. In this lab, we used LabVIEW to set up pretty much the entire game, and then we used the circuit to run the game. Yeah, I think this should be pretty good.
We're gonna play.
Yeah.
Okay, so this right here is our sub VI for our uncovered or covered photoresistors. So we start off here with a DAC assistant with the control to start it. That right here, the data, is connected to a waveform chart, which is right here on our front panel. And then it is also connected to a signal split. So we have two different photoresistors on our circuit. So the first one here, if I go to run it, we're going to show for message 2, if I cover it, it shows it's covered, uncovered, it's uncovered. So like that. And then for our first one, cover it, shows it's covered, uncovered, uncovered. And so
Okay, so here's our stepping control, stepper motor control, sub VI. The whole sub VI is contained within a while loop with inputs coming from the main VI for a number of steps to take, direction, error in. And the whole while loop will stop once it gets a message from the photo sensor sub VI. Basically, when one of the photoresistors is covered, this will say that game is ended, and then this sub VI will stop, and then the whole thing will stop. So within it we have 3 DAC assistants. The first one is for the direction control of the motor, and the last 2 are a true-false statement of how many steps to take. And so we're just going to open one of these, because right now it is wired to our stepper motor, and I'm just going to show that it is working. Okay, so here is our sound match sub VI. So what this VI does, it generates a random number between 0 and 1, multiplies that by 300 so that we can actually hear it as humans. And then it adds 205 to that so that it's a little bit easier to sing. That number goes into the simulate signal, so it will simulate actually a sine wave. And then that sine wave gets outputted to a play waveform, where you can actually hear the tone that is being simulated from that. So then the game then wants you to match that tone, so it acquires a sound of you singing, humming, however you want to generate that sound, and then it compares the two. And then that score is outputted to the main VI, which then gets inputted into the stepper motor to say how many steps the motor goes. Now, our tone generator sound match game has decided to throw a little curveball at you. So it actually outputs 2 tones at the same time. The lower tone is basically a distraction tone, and then the higher tone is the one you're actually supposed to match. And it makes it a little difficult. Okay, so here we've got our setup of our DAC with our stepper motor and our stepper motor control. So from our DAC, we're running 5 volts and ground. We're actually running that to a breadboard so that we can run 5 volts to each photoresistor and the motor itself. And then coming out of the digital side of the DAC, we've got the orange is running to step, and our blue wire is running to direction so that it can change the direction and the step. And then on our analog side, we have wires measuring the voltage drop over each photoresistor.
okay, so here's our circuit setup. On the left side here on the breadboard, we have our voltage that's coming into the circuit. On the right side here, we have our ground, which is connected to both circuits. We ground over here. So how our circuit is set up here, we have 5 volts that is coming into the photoresistor. The photoresistor also has 2 wires connecting on either end to tell if it's covered or uncovered on the port on the DAC. From the photoresistor, we have a 1K resistor that is connected to ground. It goes for both circuits are set up the same. We have the 1K resistor connected to ground here with the photoresistor, and another set of wires connected to a port on the DAC to tell if it's covered or uncovered. Alright, so this is our main VI here, our match tone game, what our game will basically run off of. We have our front panel over here, which has our speed of arm set at 2, time in between the tones set at 2, we have our direction override, our direction or stop, and then all your tone that's outputted, the target tone, the score that you get, whether the game's over, game's still going, and which player is going. Okay, so then if we go over to our block diagram here, numbers generated. If there is a remainder here, then player 2 will go. If there is not a remainder, player 1 will go. And then over here now we have a time in between tones, so basically gives us times for the next player to come up, time delay. Up here now we have 2 sub-VIs within our main VI. We have our sound match and our stepper control. With our sound match, gets our tone, target tone, and the score that we receive. Score coming out, then comes through here, goes up to the direction override. The direction, if it is true, it will come down through here through the stepper control. And stepper control will determine how far our lever moves, depending on your score once again. And then at the end here we have our status of our game and the end of it.
So we're playing the game right now. We're showing how the game will end when we cover up our photoresist. So right now it's playing, cover it up, game over,
Game
and
over.
it stops the thing.
Now we're going to play the sound matching game.
There's a problem.
Ooh. I didn't